Today we're going over a few of the basics for sequences. The first thing we're going to look at is the hierarchy of infinitives, and this will be the main hierarchy that you apply in exercises. So infinitives are just sequences that have a limit of either plus or minus infinity. And they're grouped into four categories. The first category is a factorial, which is really only one case that you'll see. Then we have the exponentials. Then the powers, and then the logs. So right now these are listed in order from highest order to lowest order. And we're talking again about sequences that tend to plus or minus infinity. So exponentials and powers, they don't necessarily tend to plus or minus infinity, but we're only going to deal with the ones that do. So for a factorial, the only one that you're really going to have is n factorial, which just means n times all the numbers before it. For exponentials, you tend to see e to the n, or any exponential with a base bigger than 1. So 2 to the n or 1.2 to the n, and so on. You're not going to see exponentials with a base between -1 and 1, because those would tend to 0. So these would be infinitesimals. And also you won't see something like e to the minus n, because when you have a negative exponent, you can rewrite that as 1 over e to the n, and that will also tend to 0. So these are just not part of the hierarchy, and we'll deal with those later. Then the powers, we're also dealing with the powers that go to plus or minus infinity. So any power with a positive power, basically. So n squared, n cubed, n to the 1/2, which is the same thing as square root, and so on. And with logs, you can have any kind of log. Usually we see ln, or logs with a base bigger than 1. So for example, log with a base of 2. Both of these cases tend to plus infinity, while if you have a log with a base between 0 and 1, it will tend to minus infinity. But either way, it's still an infinitive. So for example, we can say that n factorial is a higher order than e to the n, because it's in a higher group. And when we get to the exercises, basically this will just mean that n factorial is much more relevant with respect to e to the n. Also, between exponentials, the exponential with the biggest base will be the most relevant. So we can say that e to the n, and e is about 2.7, is going to be a higher order than 2 to the n. But if you have something like e to the n, and then negative e to the n, notice how the minus is not actually part of the exponential. It's separate. It's like a coefficient of -1. And so in general, when you have a constant multiplied by a function, the constant is not going to affect the order, which means that even though these are different sequences, they're considered to be the same order. And also, if you had something like 5n squared, that would be the same order as maybe -7n squared. So it's not just about quickness or slowness. It's specifically about the base when it comes to exponentials, and then the power when it comes to powers. So the key things that you're comparing here are the bases for the exponentials, and then the powers for the powers. So let's take a look at this sequence question. So here, for the very first thing you want to do in general with limits is look at the individual parts of your sequence. So you want to look at them individually. The idea is that a lot of people accidentally use the hierarchy of infinitives as the very first step. And the problem with that is that in most situations, you won't have all infinitives in your fraction. So the very first thing to do is just individually look at each part and find the separate limits. So if we start with 1 over ln, we know that ln tends to plus infinity. And if you're taking 1 divided by infinity, that's going to get very small. Specifically, it's going to 0 from above. So we can say 0 plus. Then we can look at e to the minus n. Notice how you have the negative exponent, which is the same thing that we saw earlier over here. And so you can rewrite this as 1 over e to the n. So for the same reason as 1 over ln, it will also approach 0 plus, so 0 from above. Then we have sin of n. Sin of n is not an infinitive. It is irregular, but it is bounded between negative 1 and positive 1. So right now we can just say that it will be a number between minus 1 and 1. Then we have n to the 100, which is a power with a positive power. And positive powers tend to plus infinity. Minus 2 to the n is an exponential. Remember that when you're looking at the order and also at the limit, we don't actually care about any numbers or negative signs in the front. So if we look at 2 to the n by itself, that will go to plus infinity because it has a base bigger than 1. And then with the minus, it will go to minus infinity. Either way, though, it's an infinitive. Then we have minus 1 to the n, which is very similar to sine and cosine. It also tends to a value between minus 1 and 1. So by itself, it's irregular. But in this case, we're going to see that it won't actually affect the limit. And lastly, we have 6/5 to the n, which is an exponential with a base a little bit bigger than 1. As long as it's bigger than 1, it's going to tend to plus infinity. And for the bottom, here we have e squared. Notice how it's not e to the n, so there actually isn't a variable in this part. And so if there's no variable, this is going to just end up being a number. So for now, we'll just write it's a number. So most likely it won't be relevant later on. 5 factorial is very similar. Again, there's no variable. So it's just going to be a big number. Minus 5/6 to the n is an exponential, but the base is between minus 1 and plus 1. So this one is going to be tending to 0. Cosine is just like sine. We have a minus, and then cosine will be between minus 1 and plus 1. N to the 4 is a power with a positive power, so this will tend to plus infinity, but with the minus it will become minus infinity. Then a 10 is just going to stay 10, and minus 5 to the n. 5 to the n will go to plus infinity, and with the minus it will become minus infinity. Notice how it's not the same thing as minus 5 in parentheses to the n, which would be irregular and unbounded. So after doing this, we notice that we don't have all infinitives or all infinitesimals, which are sequences that tend to 0. We have a combination of different limits. So when you have this, you can't apply the hierarchy right away because the hierarchy is only valid for infinitives. Or in the case of infinitesimals, you can only use it if you have infinitesimals. Since we have a combination, we're going to first start from the left, or really anywhere in the fraction, and start adding together the limits, because that's all we're doing here, adding and subtracting. If we start going from left to right, we have a limit of 0 plus another 0 plus. So right now, between 1 over ln and e minus n, we have so far a limit of 0 plus 0 plus, which is still just 0 plus. Then if we keep on going, we're adding a number between minus 1 and plus 1. So if you take 0 and you add minus 1 or you add positive 1, it's now going to become a number between minus 1 and plus 1. So what this tells us so far is that between the first three sequences, sin of n is the most relevant one. The other two, the first two, don't affect the limit so far. So far we can cancel 1 over ln and e to the minus n, because sine is the most relevant one. The next one we have goes to plus infinity. So if right now we have a value between minus 1 and plus 1, and we add infinity to either of the extremes, we're going to get infinity for the first one, and also infinity for the second one. So now the new limit for the first four parts put together is plus infinity, which means that also sin of n doesn't matter. Then between n to the 100 and minus 2 to the n, we have plus infinity minus infinity, and this is called an indeterminate form, which means that right now we don't know which one we can get rid of, but in the end, when we use a hierarchy, we can figure that out. So for now, we just say that plus infinity minus infinity, we just have to keep it the way it is. So we're keeping the n100 and also the 2 to the n. Then if we're adding minus 1 to the n, that's the number between minus 1 and plus 1. And regardless of what this is, infinity is not affected by minus 1 to the n, for the same reason that we had before. So again, we can cancel minus 1 to the n. Lastly, we have an exponential, which tends to plus infinity. So we have an addition of plus infinity, which may or may not be relevant. We're going to see that later. The idea is that we've canceled out everything that is bounded and irregular, and also everything that tends to a number, but we've kept the infinitives so far. So far for the top, we're keeping n to the 100. Then we have minus 2 to the n, and 6 over 5 to the n. And then we can go and do the same thing on the bottom. So to make this go a little quicker, we can see that we have infinitives. We have at least one infinity. And if you have an infinity, as we said before, the numbers, whether or not they're 0, either way, infinity plus or minus a number is still infinity. So anything on the bottom that is not infinitive really doesn't affect our final answer. So these two don't matter because they're just being added to minus infinity. 0 also doesn't matter. Cosine is irregular, but again, compared to infinity, because it's bounded, the limit won't be affected. And same idea with the 10. So again, we're just left with infinitives. So we're left with minus n to the 4 and minus 5 to the n. So now we can see that on the top, our limits are plus infinity, minus infinity, and plus infinity. And then minus infinity, minus infinity. So for the top, we definitely have an indeterminate form. Either way, we want to figure out what is going to be the highest order on the numerator and also in the denominator. So now that they're all infinitives, and whether they're plus or minus doesn't affect it so far, now we can use the hierarchy of infinitives that we talked about before. So on the top, we have a power, an exponential, and another exponential. So if we go back to the hierarchy, exponentials, if they're infinitives, they're always a higher order than a power infinitive. So we can definitely cancel the n to the 100. And so right now we're left with minus 2 to the n plus 6 over 5 to the n. On the bottom, it's very similar. we have a power and an exponential. So between the two, again, the exponential wins. So we keep the minus 5 to the n. Now we can go a little further and see that even though these are both exponentials, the one with a bigger base is a higher order. So 6 over 5 is 1.2, so 2 to the n is going to be a higher order. And that's the one that we're going to keep. Remember that the minus does not affect the order, so you're just comparing 2 to 6 over 5. And so if we simplify, we're left with minus 2 to the n over minus 5 to the n. If you want here, you can cancel out the minuses. And so we're left with 2 to the n over 5 to the n. And here, each part is going to plus infinity. So plus infinity over plus infinity is called an indeterminate form, which means that by itself it doesn't tell you what the answer is. And that's why we need to use a hierarchy again. So between the two, obviously the bottom has the higher base. And so we can say that we have on top a lower order infinitive. And on the bottom, you have a higher order infinitive. So you can think of lower order as just a much smaller number, and the higher is a much bigger number. So if you think about it with actual numbers, just to kind of understand the concept, the top could maybe be 1, and the bottom could be 1,000. The point is that when you divide 1 by 1,000, it's going to become a very small number. Specifically, it's going to go to 0. So even though the numbers are not exactly 1 and 1,000, this is just a general idea. And so this is going to automatically get very small, which means it's going to tend to 0. We could specify it's going to be 0 plus because we're dividing a positive number by a positive number, so it can't possibly become negative. But if one had been plus and the other had been minus, or other way around, then it would become 0 minus. So in general, if you have lower over higher, it will tend to 0. And if we had the opposite, higher over lower, now we have a much bigger number over a much smaller number. With this one, you have to be careful with the signs, whether they're plus or minus infinity. And so if you think about it backwards, where we have 1,000 on the top and 1 on the bottom, this is going to be a very big number. Theoretically, it gets very close to infinity. It can be plus or minus infinity, though, because it all depends on the signs that we have for the fraction. So it's not necessarily plus infinity. So in general, just remember that if you divide a positive number by a positive number, it will stay positive. But if you have one positive and one negative, then it's going to become negative. So these were the basics for solving a limit question with sequences. In general, the main thing that you need to be careful with is to first look at the individual limits. Most people tend to skip straight to the hierarchy and then end up taking the wrong parts of the fraction. So in general, first take the separate limits. Then if you don't have only infinitives, which we didn't have here, then you have to go through and just add all the limits. And what really always tends to happen is just that if you have an infinitive in the numerator and also in the denominator, everything that is going to 0 or to any number, or is irregular but bounded, like sine, cosine, and also minus 1 to the n, those will all become irrelevant with respect to infinitives. And so then we end up getting rid of those. So even though the question looks very complicated at the beginning, you always cancel everything out pretty quickly.